Hey, hello everyone. Welcome everyone to this classical mechanics course, and we're going to start off with kinematics. Kinematics refers to the study of motion. It's not a study of the cause of the motion, but a study of the motion itself. So, first we need to define some terms: rest and motion. What do these terms mean? Let's first come to rest. So, if an object is not moving with respect to a reference frame. Now, what is a reference frame? A reference frame is basically, well, it's a dimension from which we are looking at the object. For example, if I'm standing on the ground and then I'm looking at a car, then I am in the ground frame. So any motion around me is going to happen with respect to the ground frame. Now suppose I am inside the car. Then any motion which is going to happen around me will be with respect to the car, with respect to the car's frame. So what is the frame of reference? A frame of reference is a three-dimensional frame along with a clock to measure time. So what is rest? Let's come to rest again. When the position of an object does not move with respect to a frame of reference, with respect to a point of view, let's frame it that way, frame of reference equal to point of view. So if the position of an object is not changing from our point of view, then we say that the object is in rest. The same can be said for motion. If an object changes its position from our point of view, then we say that the object is in motion. Now, you have to understand that rest and motion are two relative terms. Relative. What does this thing mean? Well, this means that an object can both be at rest and in motion, depending on the frame of reference chosen. For example, if you're standing on the ground and you see a tree, you see that the tree is in rest because it is not changing its position, unless it's a very special tree. But in a general case, the tree does not change its position. Now you're in a car, and when you're inside of the car, you see that the objects around you are moving. If you move in this direction, the tree, which was once stationary, is now moving in the opposite direction, and you are at rest. When you are in the car, you don't see yourself going forward. Instead, you see the surroundings go backward, and that's how you infer that you are actually going forward. So when you're in the car, the tree seems to go backwards, and the tree seems to be in motion. So, from one point of view, the tree was at rest, and from one point of view, the tree is in motion. That's why rest and motion are two relative terms. An object's state of rest and an object's state of motion depends on the frame of reference. So, yeah, we have studied the frame of reference. Let's study distance and displacement. Let's come to distance. What is distance? Distance is the path length of a body. So if an object, say an object, was at point A and then traveled to point B, following this very path, then the length of this path is called the distance. For example, you're at your home and then you go like this to your school, then the length of this path is the distance you traveled to go from your house to your school. It's as easy as that. Distance is a scalar quantity. What does this mean? A scalar quantity means that the magnitude, that the distance, the measure of distance, does not depend on the direction distance has been traveled in. For example, if you're here and you go 5 meters in this direction and 5 meters in this direction, in both the cases you have traveled an equal amount of distance. Whether it be 5 meters here, 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 or here, it doesn't matter. That's called distance. Now let's come to displacement. Displacement is the change in position of an object. It's different from distance. For example, if an object was at point A, and let's imagine a Cartesian plane, two-dimensional Cartesian plane, with the y-axis here and the x-axis here, and suppose the particle was at coordinates, let's see, 1, 2. And then, after some time, you see that the particle has reached here. And coordinates, say, 8, 1. So, whatever the path the object traveled, it doesn't matter. It doesn't matter if the particle went from here, here, then here, or straight to here, it doesn't matter. What is the displacement? Displacement is the difference between this position and this position. So the displacement in this case is 8x plus 1y for this, and minus this thing, 1x plus 2y. That will give us 7x minus y. That is the displacement, where x and y are unit vectors along the respective axis. So the x is the unit vector along the x-axis, and the y is the unit vector along y-axis. So yeah, that is displacement. Now, displacement is usually represented by r vector, because it's a vector quantity. Okay, yeah, it's a vector quantity. It means that displacement depends on the direction. If you're here and you go 5 meters here and 5 meters here, the distance traveled is the same. The displacement is not. Why? Because direction is different. If you go here, then displacement is 5x. If you go here, displacement is minus 5x. That's the difference. So, displacement is usually denoted by r vector, and if we take the magnitude of this vector, we get displacement. We get distance. So r vector is displacement, and the magnitude of this is distance. Also, the distance can always be greater than or equal to displacement. It can never be less than displacement. And that's obvious. The distance is the path length, and displacement, well, is the change in position. Well, the path length cannot be less than the change in position. That's the obvious answer to this inequality. So yeah, I think that's enough for today, and if you guys like this, please tell me in the comments so I can make more of these videos. I hope to see you guys again. Thank you.